In this episode, we're going to explore the 5 simple types in Nix. They are string, path, integer, Boolean, and null. An easy way to experiment with Nix expressions is to use the Nix REPL program. Simply run nix shell -p nix REPL, and you'll be dropped into a shell where the Nix REPL program has been built and is in the path. Then just run nix REPL at the command line. Strings are a very important part of Nix, which is why there are 3 different ways to create a string literal. The first way is the double-quoted string. As you might guess, that just means surrounding the text in double quotes. We can use the nix REPL command :t to see the type of an expression. To concatenate 2 strings, we use the plus operator. As you may expect from other languages, double quote and backslash are special characters that must be escaped using a backslash. The character sequence $open curly brace is also reserved and must be escaped using a backslash. Like other languages, you can use \n for new line, \r for carriage return, and \t for tab. In this example, we escape the double quotes and insert a new line in the middle. However, this example is not very illuminating. Since nix REPL shows us the escaped form of the string, it's hard to tell that the escape sequences have any special meaning at all. What we really want to do is print the string and see what it looks like. But since Nix is pure, it does not have a print function. However, like Haskell, Nix does have a trace function. Builtins.trace will evaluate its first argument and print it on standard error, and will return the value of the second argument. Builtins.trace is really intended for debugging purposes and is not something you are likely to use in production code. Using builtins.trace, we can now see what \n really does. In a string, the $curly brace syntax is used for anti-quotation. In this context, anti-quotation is really just a fancy word for string substitution. The ... is any expression which evaluates to a string, path, or derivation. For example, while there is no reason to, we could write hello world like this. In practice, it would be more common to see anti-quotation used with a variable. We will cover let expressions later. A second type of string literal in Nix is the indented string. An indented string is surrounded by double single quotes. This is just alternative syntax. The value is still just a string. In fact, it's exactly the same string. In indented strings, only double single quote and $curly brace have special meaning. This means you can use double quotes and backslash without having to escape them. If we actually wanted the \n to insert a new line, then we would need to escape it as single quote, \n. Likewise, to escape $open curly brace, we would need to write single quote, $open curly brace. To escape single quote, we only need to prefix it with one additional single quote. Indented strings have multi-line support. Unfortunately, Nix REPL does not implement multi-line support, so you will not be able to test this feature interactively. The leading indentation is automatically stripped from multi-line strings, hence the name indented strings. This allows you to keep things neatly indented in your code. The stripping algorithm strips from each line a number of spaces equal to the minimal indentation of the string as a whole. So, if you wrote, this is line 1, this is line 2, this is line 3, where the first line is indented 3 spaces, the second line is indented 2 spaces, and the third line is indented 4 spaces, Nix would strip 2 spaces from the start of each line, resulting in, this is line 1, this is line 2, this is line 3. Since the remainder of the line after the opening double single quotes is exclusively white space, it is ignored and not included in the string literal. The combination of multi-line support, indentation stripping, uncommon reserved character sequences, and escaping rules make indented strings ideal for embedding shell scripts and configuration files in your Nix expressions. For example, consider the following Nix expression. This snippet specifies a post-install shell script The double quotes in echo hello world do not require any special treatment since double quotes are not reserved characters in an indented string. In the last line of the post-install script, we see anti-quotation used to do a bit of metaprogramming. The third way of creating a string literal is to write a URI without double quotes. This is just a bit of syntactic sugar. The value is still just a string. There is no special URI type. It's the same value as if we had written the URI with double quotes. A path value represents a path on the local file system. A path literal is not double quoted and it must contain a slash. Without the slash, Nix will think you are referring to a variable. A path also never ends with a trailing slash. In Nix, path and string are different types. /foo is a path, but double-quoted /foo is a string. And if we test them for equality, they are never equal. A path can be converted to a string using the toString function. When a path is used with anti-quotation, it is not merely converted to a string. We will revisit this unexpected output when we learn about the Nix store. A relative path will be automatically converted to an absolute path at parse time relative to the directory of the Nix expression that contained it. For example, if the file /foo/bar/default.nix refers to /baz/extra.nix, the expression would evaluate to the absolute path /foo/baz/extra.nix. If we use Nix REPL, we can see that the path is made absolute relative to the directory we were in when we started Nix REPL. Because a path must contain a slash, we cannot use dot to refer to the current directory. The common workaround is to use the more redundant form dot/dot instead. The redundant form dot/dot is not a special hack in Nix itself. The same thing also works in Bash. Sometimes we need to refer to a path that could be different for different users. For example, we may want to refer to the Nix packages directory, but we don't know where the user has checked out Nix packages. The Nix path environment variable specifies a colon-separated list of paths to search. In a Nix expression, paths enclosed in angle brackets will be searched for in the paths specified by Nix path. For example, I checked out Nix packages to /users/stepcut/Nix packages. So, if I set Nix path to point to that directory, then I can write angle brackets lib and Nix will find it. If I try to refer to a directory not found in the search path, I will get an error. A directory like lib could exist multiple places in the search path. In order to reduce ambiguity, we can also use prefixes. Let's say I have a Nix path with myHome equals /users/stepcut. Now I can use myHome in an angle bracket expression. An element in the search path can also refer to a tarball, which is to be downloaded via HTTP or HTTPS. The tarball must contain a single top-level directory. So if we had this Nix path, then Nix would automatically download the latest revision of the Nix OS 14.2 channel and unpack it to a temporary directory. Many Nix commands take the -I option as a way to extend the search path. In the case of conflicts, the -I takes precedence over Nix path. In Nix 1.11, the only numeric type is integer. It turns out support for floats was added to master back in January of 2016, so by the time you watch this, Nix may also have floats. The Nix integer type is implemented using a C++ long, so it's either a 32-bit or 64-bit value depending on your system, most likely a 64-bit. The only way to express an integer is to write it out as a sequence of digits. As you would expect, negative numbers are prefixed with a minus sign. There is support for the 4 basic integer operations: addition, subtraction, division, and multiplication. There is also support for comparison and equality operators, such as less than or equals, greater than or equals, and not equals. There does not appear to be support for modulo, remainders, exponents, or other fancy math stuff. The Boolean type has two values, true and false. The Boolean literals are always written lowercase. The standard equality and Boolean operators you would expect are available. Nix supports equals, not equals, and, or, not. There is also a logical implication operator. Implication means that if E1 is true, then E2 must also be true in order for the whole expression to be true. But if E1 is false, it doesn't matter what E2 is. So the only time it is false is if E1 is true and E2 is false. It is equivalent to not E1 or E2. There is no exclusive OR operator. The final simple value that Nix supports is null. It has the type null, and the only value is null. The equals and not equals operators support the null type. Note that unlike some languages, the empty string is not equal to null. So far we have mostly used the equality operators equals and not equals to compare two values that have the same type. The equality operators can also be used on values that do not have the same type. Values which do not have the same type are never equal. The comparison operators less than or equals, greater than, and greater than or equals can only be used with strings, paths, and integers, and both arguments must be the same type. The not operator can only be used with Boolean values. Next time we will look at the two collection types in Nix, list and set. If you enjoyed this, please like and subscribe. If you enjoyed this video and would like me to get the next episode done faster, please consider sponsoring me at patreon.com/Haskell and Nix.